On our next project, this team was very interested in doing something ambitious. They wanted to tackle all sorts of algorithmic and performance issues, technical challenges. Once again, we have that very favorite genre of full stack teams, which are games. And they're going to show you how they translated a lot of very generic solutions into their specific framework, having a lot of fun while doing so. Go ahead, guys.
Hello, everybody. Thank you for joining us today. My name is Ryan Skinner. This is Jacob Cohen, Christopher Rizzo, and Charlie Shih. And together we created the game Gen Z. So Gen Z is an online multiplayer battle arena in which players progress by ranking their gun levels up as a result of defeating other competitors. Players can utilize features such as active reload, picking up power-ups and their line of sight to their advantage in order to beef up their players' stats, sneak around the map, and get a jump on other players. To implement this game, we decided to use Socket.io to manage the real-time player updates, Phaser.js as our game engine library, and Redux.js to manage the overall state of our game on both the front end and the back end. Marrying these three libraries together to create one cohesive game brought about many challenges within our development process. And to talk more about how we were able to create such an immersive environment for our users, here is Jacob.
Thanks, Ryan. To create this engaging experience, first we look to sound, where we have enemy gunfire get quieter as the characters get farther away from each other, which means that you, the player, have more spatial awareness of the game state. Second, we created this flashlight effect, which we believe to be an integral part of the game experience. Other players are hidden unless they're within your flashlight beam, which means you have to be constantly aware of your surroundings lest your enemies sneak up on you. To create this effect, we overlaid a bitmap on top of the world map where the user would shoot out hundreds of rays in a specific direction every second. And anytime these rays hit a piece of the bitmap wall, they stopped. We added up all these rays together to create an area called the visibility polygon, which was then masked against an image of the map itself. This makes the game intense and action-packed. However, at this point in implementation, ran into some issues with the server and multiplayer lag, which Chris will discuss now.
Thank you, Jacob. Naturally, in developing a real-time multiplayer action game, one of our main focuses and challenges was keeping events in sync across all of the players. The game would be incredibly frustrating if you were firing bullets at players that were not taking damage or attempting to collect power-ups that have already been taken. To combat the effects of network lag, we developed a few of our own solutions. Firstly, we decided to have each client send to the server a package containing all information about their state and action every 33 milliseconds. The server then aggregates this information and sends it back to the client so that they can update their games with the actions of other players. This resulted in one update per frame for a target of 30 frames per second. However, once all of the packages were aggregated, we still had problems with one-time events such as players firing bullets. WebSockets are not the most reliable technology, and packets can occasionally be lost or missing. If a packet was lost containing information about one of these states, the client would never process that event and its state would fall further out of sync from the other clients. To solve this issue, we developed a system by which each event is sent out repeatedly over a period of time. Upon receiving an event for the first time, the client would process that event and then store it in a way that it will not process the same event twice. By handling events in this manner, we ensure that each client receives and acts on every single event, regardless of network lag causing the event to arrive a few packets late. Now to talk more about our single-player experience, here's Charlie Shih.
Thanks a lot, Christopher. Now, we've been talking a lot about multiplayer today, but what if you didn't have any friends to play with, or you just need to practice? Well, there's a mode just for you as well. It's a single-player swarm mode where players can face off against hordes of the Walking Dead. Now, in order to do this, we need to implement pathfinding AI, and there were a couple of different solutions we looked into, such as Dijkstra's, Breadth First Search, and Flowfield. But we decided on a modification of the A-star algorithm. Now, A-star is traditionally used for slower tile-based games, so it doesn't really lend itself well to a hectic, fast-paced shooter like Gen Z. So in order to combat the issues with A-star, we had to implement our own smoothing algorithm on top, as well as change the way that A-star calculates those waypoint costs in order to come up with a more realistic, yet computationally similar methodology. So, if you guys are looking to scratch that competitive edge, we here at the Gen Z team welcome you to join us at genz.herokuapp.com. Thank you. Have a great day.
All right, I'm playing right now. Yeah, no, that's cool. I love the use of algorithms, but also the game itself looks a lot of fun. It reminds me of Smash TV meets The Walking Dead meets that flashlight effect. What's that game? Amnesia.
Yeah, it's funny. During some of my code reviews, I have to confess that not all of the code review was actually spent reviewing code. Some of it certainly was spent just wandering around, tumbling, firing various guns, etc.
Yeah, it's well done. All the makings of a AAA indie title.
Very impressive.